एग्जाम दे सकते।
नहीं सर, कैमरा ऑन होता है।
नहीं सर, ऐसा नहीं है। क्या बोल रहे हो?
कैमरा ऑन होता है सर, ऐसे कैसे कर ले? सर टीचर तो 20-20 में सर बोलते हैं कि आधार कार्ड दिखाओ, पासपोर्ट।
हाँ, कैमरा तो ऑन होता है, वो तो पता है।
तो आज रहने देते हैं ना।
अब वो फैकल्टी के ऊपर डिपेंड करता है। तो क्या आज पढ़ने के मूड में नहीं हो क्या?
नहीं सर।
नहीं सर, प्लीज सर, आज छोड़ दिए।
वैष्णवी
सर कल एग्जाम खत्म हुआ है और
वैष्णवी क्या बोलते
असाइनमेंट है
हैं,
सर।
सुनते हैं।
यस सर, क्या बोल रहे हैं?
असाइनमेंट पर
वही
भरती
ना
है
सर,
सर।
फिर असाइनमेंट भी है।
2 4 5 असाइनमेंट है।
यस सर।
सर आपने भी असाइनमेंट दिया ना सर?
ये वैष्णवी कुछ नहीं
सर आपने तो एग्जाम खत्म होते ही आपको
सर
असाइनमेंट
कुछ
भेज
बोल
दिया
रहे हैं
सर।
क्या?
मैथ्स का एग्जाम खत्म हो गया था।
हाँ सर।
सर सबमिशन डेट थोड़ा एक्सटेंड कर दीजिए।
हाँ, मेरा तो असाइनमेंट
सर हम लोग को अभी बीएमएस एईसी दोनों का सर।
मेरा असाइनमेंट तो बहुत दिन अभी 7 दिन मेरा जो असाइनमेंट है वो 7 दिन का डेडलाइन है, तुम आराम से कर।
ट्यूसडे है ना
नहीं, मैथ असाइनमेंट का डेट एक्सटेंड हरगिज नहीं करेंगे, क्योंकि 7 में 1 दिन लगेगा। हाँ,
तो आपका साउंड बीच में थोड़ा लैग करके आ रहा था सर।
वो आपका वॉइस बीच-बीच में कट जा रहा है।
ठीक है, चलो आज एक मतलब एक ओडी सॉल्व करते हैं।
यस सर।
ओके सर, ओके सर।
वन ओडी सर डन।
ओके
सेम प्रॉब्लम। What, am I audible or not?
सर आपका वॉइस बीच में कट रहा है, लेकिन अभी ठीक है।
Now it is okay.
Yes sir, yes sir. Now you are perfectly audible.
Yes sir.
Okay. Look, like Frobenius method here also, मतलब ऐसे प्रॉब्लम मिल सकता है ओडी सॉल्विंग बाय यूजिंग लैपलेस ट्रांसफॉर्म, जो टाइम टेकिंग है। वैसे लास्ट दिन ये प्रॉब्लम करवाया था ना, जिसमें पूरा क्लास ही लग गया था शायद।
यस
तो ऐसे प्रॉब्लम लैपलेस में भी है कि जिसमें ओडी सॉल्विंग बाय लैपलेस ट्रांसफॉर्म टाइप का क्वेश्चन रहता है। तो अगर वो डिपेंडिंग ऑन क्वेश्चन, ठीक है, कोई भी एक ओडी आसानी से सॉल्व हो जाता है, और कोई भी एक ओडी का जो एफएस है वो कॉम्प्लिकेटेड फॉर्म में आ जाता है। वो प्रॉब्लम के ऊपर डिपेंड करता है, हर एक प्रॉब्लम बड़ा नहीं होता है। तो फ्रॉम प्रॉब्लम नंबर 1 to 11 आई हैव सॉल्व 2 प्रॉब्लम्स इन द लास्ट क्लास और लास्ट 2 क्लासेस। तो today देखो, I'm going to solve a different type of problem, not exactly means so many different, I can say just difference is that you read the problem, like problem number 12 or 13. What is the difference with the problems in the range 1 to 11? Initial value. You see, in 1 to 11, the initial values are at the point 0, y0, y dash 0, right?
Yes.
But 12 to 15, you can see the initial values are not exactly 0. It is 2, 4. So if these type of values are given, y4, y dash 4. So after taking Laplace transform, immediately you cannot put the value, because whenever you took Laplace transform, it appears in the form y0, y dash 0, right? Do you remember or not? I am showing. देखो अगर वो y डैश एंड y डबल डैश का डेरिवेटिव देखते हैं फॉर्मूला, तो लैप्लास ट्रांसफॉर्म ऑफ f डैश दैट इज l s into Laplace transform of f minus f0, and Laplace transform of f double dash a square Laplace transform of f minus f s f0 minus f dash 0. Now you see, if f is y, if you think f as y, then in place of f you put y. Okay. Now y0 and y dash 0. If you take Laplace transform, you will get y0, y dash 0, right? On a differential equation, if you take Laplace transform, you will get y0 and y dash 0 by this formula. Do you agree? Are you getting or not what I am saying?
Yes, sir.
Okay, I am showing you by an example. That is the last problem I had solved. See, the form of the OD, like I am taking a simple example, y double dash plus 2y is equal to something, whatever. So if you take Laplace transform on both sides, okay, so it will be Laplace transform of y double dash plus 2 into Laplace transform of y is equal to Laplace transform of whatever it is given in the right hand side. Now you apply the formula for double derivative. So it will be a square Laplace transform of y minus what? S f0 minus not f0, y0, right? y0 minus y dash 0 plus 2 Laplace transform of y is equal to Laplace transform of something. So after taking Laplace transform and applying the formula for derivatives, we will get this type of equation, which contains y0, y dash 0, right?
Yes, sir.
Now, in the problems from 1 to 11, just a minute. In the problem range 1 to 11, you see y0 and y dash 0 both are given. If it is a second order, y0 and y dash 0 both are given. All the initial values for each problem you see y0, y dash 0, y0, y dash 0. Okay. So we can directly put these values to that last equation. मतलब ऐसे फॉर्म में जो इक्वेशन आएगा यहाँ पे y0 and y dash 0 का वैल्यू we can put. But if this type of problems are given from problem number 12 to 15, okay, they have given y4 and y dash 4. So where I will put? It is y0 and y dash 0 according to the formula. तो y4 y dash 4 वो पुट करने का जगह नहीं है. तो what I will do after that? Right. Sorry. Do you get it? Means what is the problem here? Whenever the initial value does not start with 0, we cannot apply it here. y4 y-4 कैसे अप्लाई करेंगे? समझ में आया कि नहीं? क्या प्रॉब्लम है यहाँ पे? Tell me.
Sir?
Are you getting? I mean, so what is the
Yes, sir.
problem we are getting? Still, there are some voice lag or is it?
No, sir. It's
No, sir. No voice lag, sir. It's clear, sir.
Okay. Now, to overcome this issue, what we will do? See, we will take some substitution, some shift. We will do some shifting. Okay, shifting of data. That is why these problems are called shifting data problem. Actually, the initial variable t, we will shift it so that the initial condition changes to 0. Okay, we will shift the data. So shift means basically a substitution is needed. So what kind of substitution you will take? Here y is a function of t. Okay, the independent variable is t and the dependent variable it is y. I am showing you now. Problem number 13. It is a simple one, first order differential equation. So you can do it yourself. I am showing some other like. Okay, I am taking problem number 14. It may be large, I don't know. I am taking problem number 14. Y double dash plus 2y double dash 2y dash plus 5y 50t minus 100 na 50t minus 100 y2 minus 4 y dash to 14. This y double dash plus 2y dash plus 5y. Okay, now see what I am doing. So as I told, we have to take some substitution. So first of all, we will shift the data and change the OD. Okay, so we take a new variable t bar. Okay, a new variable t bar, which is t minus t naught. T naught means the initial t value. Now here t naught is 2. Okay, initial value for t, that is 2. Therefore our substitution is p bar is equal to t minus 2. Okay,
Yes.
अगर मान लो कि y at 4 दिया है, y at 4, y dash at 4, then what will be your substitution?
T minus 4.
t minus 4. अगर minus 1 दिया है, y at minus 1, y dash at minus 1,
T plus 1.
t plus 1. Okay, so this type of substitution we have to take. Now according to that substitution, t क्या हो जाएगा? t will be t bar plus 2. T bar is equal to t minus 2, so t will be t bar plus 2. Now you change the derivatives, y double dash, y dash. This y dash means what? dy by dt. Now, if you want to change it to dy by dt bar, okay, dy by dt bar. Actually, by linear relation, the derivative remains unchanged. मतलब d यहाँ पे ये वाला रिलेशन होल्ड करेगा, dy by dt जो है ना वो dy by dt बार के साथ बराबर होगा. And similarly double derivative. So there are no change in derivatives. Okay. If you take this type of linear substitution, no changes derivatives. So ultimately the equation changes to what? Y double dash plus, but this y dash, keep in mind ये y double dash क्या है? dy by dt बार है. Okay. 2y dash 5 y, you change that t, so t is equal to what? T bar plus 2, to put it here right hand side क्या होगा? 50 t bar plus 100 minus 100, so only 50 t bar. Okay. Now इनिशियल कंडीशंस क्या हो जाएगा? y at what? Y at, that is t is equal to 2. Y at t is equal to 2, that is minus 4. तो ये चेंज होगा, क्या हो जाएगा बोलो? टी बार का अगर टी बार में कन्वर्ट करेंगे तो क्या हो जाएगा?
फिर 0.
Yes, means y at t bar that is equals to 0, minus 4, and y dash at 0 it is 14. This 0, ये जो दोनों 0 है, ये 0 किसका वैल्यू है? t बार का. Okay. If you put t is equal to 2, then t bar 0 ना. Now we
Sir?
can, हाँ.
Sir, why is minus 100?
क्या हुआ बोलो?
Sir, minus 100.
Minus 100 कहाँ गया?
Yes, sir.
In the above equation, you put t is equal to t bar plus 2. I have put t is equal to t bar plus 2.
Cancel हो जाएगा. Yes, sir.
हाँ. Do you get it or any doubt? Tell me.
No, sir, no doubt.
Others? Now you take Laplace transform. So Laplace transform of y double dash plus or 2 Laplace transform of y dash plus 5 Laplace transform of y, 50 Laplace transform of t bar. Now Laplace transform of y double dash means what? A square Laplace transform of y, which is a function of t bar. Fine. S y 0 y dash 0 plus 2s Laplace transform of y minus 2 y 0 plus 5 Laplace transform of y is equal to, right hand side it is actually that t, Laplace transform of t. t bar, that means t. Not do not think that t, okay, means t bar ये एक नया वेरिएबल है एंड वो t bar मतलब वो एक पॉलिनोमियल जैसा ही है, t के लिए जो होता है वही, तो it will be a square 1 by square, right? Laplace transform of t bar.
Yes, sir.
Now put the value of y0 and y dash 0. So I am taking L of y common. So a square plus 2s plus 5. A square plus 2s plus 5. L of y. Next s y0 minus s y0. तो ये हो जाएगा 4s and here also that is 2y0. Okay, are there any other s? It is only 4s na? Yes, it is 4s. Y dash 0. Y dash 0 means 14. So minus 14 and 2y0 8 minus 14 plus 8 क्या हो जाएगा 6 plus 6 plus 6 is equal to 50 divided by a square. Okay, so a square plus 2s plus 5 Laplace transform of y 50 divided by a square minus of 4s plus 6. I am keeping it in that form. Therefore Laplace transform of y, it will be 50 divided by a square into a square plus 2s plus 5. Can we factorize it? No, not possible, na? It is not possible to factorize it.
No.
This now we have to find Laplace inverse. Okay, Laplace inverse. So can you find the Laplace inverse of these two terms? Laplace inverse of 50 divided by a square into a square plus 2s plus 5 minus Laplace inverse of 4s plus 6 divided by a square plus 2s plus 5. Here that y means y is a function of t bar. Okay, that y, it is a function of t bar, because now we are doing every calculation in the variable t bar, right? So it is, I'm not writing, no need to write that variable t bar. But here after taking Laplace inverse, do not write the inverse in the form, in the function of t. You write it in the function of t bar. Okay, इसमें t लिखना मत. Laplace inverse आने के बाद जो by the formula आएगा उसमें t bar लिखेंगे. So I'm doing in two parts. First part, Laplace inverse of 50 divided by a square into a square plus 2s plus 5. Now tell me how to find that inverse. Look, fs by s, I told na, fs by s repeated application of that formula. Fs by s, first step में you find fs by s, in second step you find again that by s. जब fs by s वाला दो बार अप्लाई होता है ना यहाँ पे.
Yes, sir.
तो इसको fs ले लेते हैं 50 बाई a स्क्वायर प्लस 2s प्लस 5. तो लैप्लास इनवर्स ऑफ fs बाई s क्या होगा? मतलब पहले अभी फर्स्ट क्या कर रहे हैं कि डिवाइडेड बाय s वाला जो है वो कर रहे हैं, और एक नेक्स्ट स्टेप में a स्क्वायर. आई हैव शोन ना द ट्रिक टू सॉल्व दिस a स्क्वायर और s क्यूब इन दिस फॉर्म. डू यू रिमेंबर और नॉट? fs by s, that means in the first step I am finding Laplace inverse of 50 divided by s into a square plus 2s plus 5. Okay, so what is it? Tell me, what is the formula? 0 to t f tau d tau, or ft dt also you can write this. Okay, now what is ft? ft क्या होगा बोलो? fs से ft निकाल लो. How to find ft? 50 divided by arrange it in the form of whole square. So s plus 1 whole square plus 2 square, right? So if you take now Laplace inverse of fs, you will get ft. It is what? It is actually Laplace inverse form of s shifting. In s shifting, small a it is -1 and rest it is constant by a स्क्वायर प्लस a स्क्वायर. तो क्या होगा बोल सकते हो? ft e to the power, tell me, e to the power minus t, and ft e to the power 80 into that ft. so वो क्या हो जाएगा? टू बाई करेंगे तो साइन, तो 25 साइन 2t. तो अल्टीमेटली इट इज 25 e to the power minus t sin 2t. okay, so you have to solve this integration 0 to t 25 e to the power minus t sin 2t. It is not that much easier. Have you remembered the formula for integration e to the power at sin bt? So I am giving you this as homework. You complete that integration. तो ये होगा, and after that you find Laplace inverse of fs by a square. fs by a square, that is again integration 0 to t. In the previous step whatever you will get, you integrate that from 0 to t. It will be fs by a square. Okay, I am writing it as star. तो जो भी मिलेगा star, you integrate that star, you will get ultimately the answer of the first part. Okay, Laplace inverse of 50 by a square into a square plus 2s plus 5. And for the second part, it is Laplace inverse of what? 4s plus 6. 4s plus 6 divided by a square plus 2s plus 5. So it will be Laplace inverse of 4s plus 4 plus 2 divided by s plus 1 whole square plus 2 square. So Laplace inverse of 4 into s plus 1 divided by s plus 1 whole square plus 2 square plus Laplace inverse of 2 divided by s plus 1 whole square. It is simple one, 2 square. Any doubt here? Look, overall I have to bring it in the form of function of s plus 1 na? So it is now a function of s plus 1. Both are function of s plus 1. Now for the both term you apply s shifting, Laplace inverse of s shifting. Okay, क्या होगा बोलो? First क्या होगा? What is small a? According to s shifting, it is a function of s plus 1. So what is small a? Directly you can write. Okay. e to the power 80 into ft ना, तो a क्या है? Tell me. -1.
So 1 -1.
-1. So e to the power -1 into t. And from that you will get fs, that will be s by a square plus 2 square. So what is ft? s by a square plus 2 square cos na, cos 2t. Okay, and second part, tell me similarly a minus 1, so e to the power minus t, and a by a square plus a square, it is sin 80. So sin 2t. It is simple. Second part is simple. Any doubt? In any part, if you need explanation, you can ask me. I will explain. देखो एज शिफ्टिंग हर जगह पे यूज होता है, एज शिफ्टिंग भूलना मत. एज शिफ्टिंग means forward and backward both, Laplace and Laplace inverse, both formula you have to remember, because you can means you can directly use it, and for most of the problem we need that age shifting. बोलो कोई एक्सप्लेनेशन चाहिए यहाँ पे? कहीं पे लग रहा है कि स्टेप जंप है, मतलब तुम लोगों को समझ में नहीं आ रहा है?
No, sir.
So complete the previous part. Okay, it will take some time. you complete that integration. First of all, you see integration formula. You can do in islet form also, but better to use the formula directly from the book. So if you have 10 plus 2 level book, you can check it. I think in the project book also it is given in the first page. Let me check. This, okay. This formula I am talking about. So there I need this formula, na? E to the power ax into sine bx. You check it and apply it. Right? You can do. And then whatever you will get, you integrate that from 0 to t again. I will ask in the next class. Okay, and here actually whatever t I have written, that is not exactly t. These are t bar. Better to write t bar. Okay. These are all t bar. And this also. For the next part also, these are t bar. Okay. And after getting the Laplace inverse for the first part, in the first part, you ultimately put it here. First part minus second part. And lastly, you substitute that t bar. Okay. T bar, that is what? T minus 2. Lastly, you substitute this. You complete it. I will ask in the next class the final means answer. Okay, the final answer for this means answer of this. Okay, that's all for today. I'm taking attendance now. Okay, I will give all present.
Okay, sir.
Okay, sir. Thank you, sir.
Okay, sir. Thank you, sir.
Thank you all.
Thank you.
Thank you, sir.
Very interesting. Thank you, sir.